Okay, there were a couple questions here. For the FEX connections, is it like an Ether channel that the flow can only use one link? Yes, that is true. So when you look at the specific load balancing of an individual server, and let's say you're doing like a TCP download, you're doing a test like with iPerf to check the throughput. If you only have one individual connection, that one connection will always hash to one physical port. Now the specific hashing mechanism, we're going to talk about this in more detail when we look at port channeling and the basic layer 2 configurations. You can change the port channel load balancing method. So you could say, for example, I want to include the source and destination IP address in addition to the port number. This would try to distribute the traffic between the links a little bit better. But ultimately, an individual flow can only use one of the member ports as it goes from the FEX up to the parent switches. So just like a regular port channel or a VPC, the flow is, the effective flow bandwidth is always going to be based on the lowest speed of one of your member links. So you can't do a file download that is a throughput of more than 10 gig unless you do like multiple segments of the download in order to create multiple flows. Okay, there's a question, does the FEX have any intelligence that you need to configure? No, it does not. So the only thing that the FEX needs to know is what is the line card number that you're giving it, and that you need to send it the VN tag formatted frames. Everything beyond this, it's going to happen automatically. So when you look at the 2K physically, and actually let's take a look at this from the data sheets point of view. If we go to cisco.com/go/nexus and we go to products, Nexus, 2000 data sheets, and let's say fabric extender data sheets, and let's see if it shows a physical. It doesn't really show a great physical view. Let me search for an image of it. Let's say 2232 pp is the part number. So this is, okay, the hardware installation guide. Okay, so this is the back of the chassis. Basically, the only thing that's here is the fans and the power supply. There's no console. The same is true with the front of it. So you have the LEDs, you have the downlinks where these go down to the servers, and then you have the uplinks that go up to the parent switch. Okay, these ports here, these are the ones that are running VN tag. These ports down here, these are the ones that are running Ethernet. But what's interesting about the platform is that there's no console port. So you cannot telnet to it, you cannot serial connect to it. You have to just plug the uplinks into the parent switch. The parent switch automatically discovers it and then downloads the configuration towards it. So again, you cannot use it as a standalone switch. It has to have a parent switch northbound of it in order to control it through the VN tag protocol. There's a question, can I explain the concept of static pinning and what's the advantage of using the max pinning? This is essentially similar to what we had talked about in the UCS world about when you plug the fabric interconnect down to the I/O module. We have the option of doing static pinning of the blades to the I/O module up, or we have the option of configuring it as a port channel and then doing load balancing between them. Now, in the case of the Nexus 2K fabric extender, it's exactly the same logic. So let's say, for example, that we have our 5K upstream, and that we have let's say we have just one link that goes down to the extender. So this is 2232. So it has ports 1 through 32 that are facing down to the servers. Okay, this is 10 gig. This means that if we plug an end host into port number 1, or we plug an end host into port number 32, all of their traffic as they go northbound is always going to go over this one uplink. Because there's only one connection to the fabric. It only has one way to switch northbound to the parent switch. But now let's say that we plug in 2 different uplinks. So we have the option to go over uplink 1. We also have the option to go over uplink 2. Now with the default configuration, what is going to happen is that the FEX is basically now going to be split into two different port groups. It's going to be split into ports 1 through 15, and it's going to be split into 16, actually no, I think it's 1 through 16, and then 17 to 32. So this means that if you plug your server physically into port number 10, you're going to use the first uplink. But if you plug your server into port number 18, you're going to be using the second uplink. And the way that you can see this is from the CLI point of view, is when you look at the show FEX detail. It tells you for the specific server-facing interface, what is the fabric port that we're using when we send the traffic from the 2K north to the 5K. So right now it says that we're doing static pinning to one link. This configuration, it technically doesn't make any difference because there's only one port physically plugged in from the 2K up to the 5K. The only thing that this is going to affect is that if you start to add additional uplinks. So let's say now that we add 2 more uplinks. So we have uplink 3 and 4. We're now breaking the downstream facing ports into 4 port groups. So we're going to have ports 1 through 8. We're going to have 9 through 16. And so on and so forth. So depending on how you physically wire, if you plug your server into port number 15, you're going to use the second uplink in the group. Now, the disadvantage of doing this, though, is that if that uplink fails, the downstream servers lose connectivity. So it's not necessarily as common a design. The reason that you would mainly do this is that if you want to dedicate bandwidth to an individual server, you would plug them into a port group that doesn't have any other downstream facing devices. So let's say that we split it into 8 port groups by configuring all 8 uplinks, or by plugging all 8 uplinks from the FEX to the 5K. This means that we're going to have port groupings of 4 ports. So just like we had on the M132 card. So this means ports 1 through 4 are in port grouping 1. If we only plug one server in there and leave the other 3 ports vacant, so leave them empty, it means that we're going to be dedicated one uplink as we go towards the parent switch. Now, a more common design, though, would be to configure this as a port channel. So when you configure it as a port channel, all of the downstream facing ports dynamically pin to the port channel, which means that if one of the physical interfaces goes down, you just rehash the traffic over the rest of the members in the channel. Also, the other advantage of doing the channeling is that you have the aggregate of all of the bandwidth of all of the uplinks. So if you're using all 8 of them, you have 80 gig potential going to the fabric. If you do static pinning, you always have 10 gig divided by however many ports that are in your port group being used. So if your port group is 8 ports, your oversubscription ratio is going to be 10 to 1, or 10 to 8. And the way that you change this, and we'll look at this in a little bit more detail later when we configure virtual port channels, but the way that you would change this is to basically go to the FEX port and then to put it in a channel. So let's say channel group 100. And if we show FEX detail, we see now the fabric port is the port channel. So it means that all of these interfaces would be bound to port channel 100. So if I add an extra uplink, if I add E112 or E114, whatever the physical ports are, as long as we just put those into the channel, then they would automatically start to load balance for the downstream facing interfaces.